Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2183 indicates a performance problem with the Engine Coolant Temperature Sensor 2 on the 2023 Honda Accord. The ECT sensor measures the temperature of the engine coolant, which is crucial for the vehicle's engine control module, ECM, to optimize engine performance, control fuel injection, and monitor engine heat levels. ECT Sensor 2 is distinct from ECT Sensor 1, with both sensors located near the engine block, playing a pivotal role in ensuring the correct operating temperature is maintained. If either sensor provides inconsistent temperature readings, the Powertrain Control Module, PCM, detects this anomaly, storing the DTC P2183. To effectively address this code, technicians will need to follow a systematic troubleshooting approach that involves inspection of the ECT sensors, their wiring, and related components. DTC P2183 signifies that there's a reported issue with the ECT Sensor 2 circuit. This sensor is instrumental for accurate temperature readings and operates in tandem with ECT Sensor 1 and Intake Air Temperature IAT Sensor 1. The PCM constantly monitors these readings for discrepancies. When it identifies significant differences in temperatures measured by these sensors, it categorizes this as a performance issue, ultimately leading to the storage of DTC P2183. The location of ECT Sensor 2 is important as it must correctly gauge the temperature of the coolant flowing through the engine. The health of this sensor is vital for preventing engine overheating or fuel inefficiency, which can lead to costly repairs if not addressed promptly. Several potential causes can lead to the generation of DTC P2183. One prominent reason is a faulty ECT Sensor 2 itself, which may provide incorrect readings due to internal malfunctions. Additionally, poor electrical connections could result from corroded terminals or loose plugs, causing unreliable sensor performance. Furthermore, a damaged wiring harness can short or interrupt the signals being sent to the PCM, which might mislead the system into diagnosing a performance issue. Problems could also arise due to temperature measurement discrepancies between ECT Sensor 2 and its counterpart Sensor 1. Understanding these causes is an essential first step in effectively diagnosing and resolving the error code. When the DTC P2183 is present, drivers may experience various symptoms linked to engine performance issues. One common symptom is inconsistent engine behavior, such as stalling or rough idling, often due to incorrect fuel mapping influenced by erroneous coolant temperature readings. Another visible indicator is a warning light on the dashboard that alerts the driver to a potential engine anomaly requiring attention. Moreover, if the ECT sensor is not accurately reading the engine's coolant temperature, it can cause overheating, putting the engine at risk for severe damage. Recognizing these symptoms can help in timely diagnostics and prevent further complications in the vehicle's performance. The first step in troubleshooting DTC P2183 involves properly preparing the vehicle for inspection. Begin by turning the vehicle to the off lock mode and allowing it to rest for a minimum of 6 hours. This cooling period is crucial as it allows components connected to the ECT sensor to stabilize. Then, start the engine and let it idle for at least 10 seconds. This short idling period helps confirm the operational status of the ECT sensors upon initial startup. Monitoring how the engine behaves during this time can provide essential clues regarding whether the issue persists after a cooling period, laying the groundwork for further diagnostics. The second troubleshooting step focuses on inspecting the connectors associated with ECT sensors 1 and 2. At this stage, a thorough visual inspection is key to identifying any immediate issues with the connectors, such as corrosion, loose terminals, or damaged pins. A secure connection is essential for proper signal transmission between the sensors and the PCM. Any defects found during this inspection could be a significant contributor to the DTC P2183 fault. If the inspection reveals any abnormalities, rectifying these connection issues may resolve the performance problem without further component replacement. Next, carry out a functional inspection of ECT Sensor 1. Begin by starting the engine and allowing it to idle for approximately 10 minutes, which enables the system to reach optimal operating conditions. Utilize the HDS, Honda Diagnostics System, to confirm that the ECT Sensor 1 value registers above 120 degrees Fahrenheit, 49 degrees Celsius. This threshold is crucial. If the reading falls below this value, it indicates a malfunction in ECT Sensor 1, contributing to the erroneous DTC P2183. It's essential to document these values, as they are paramount for further diagnostics and will guide subsequent inspections. In this step, the focus shifts to inspecting ECT Sensor 1 for any physical anomalies. Allow the sensor to cool down to ambient temperature before noting the current temperature around it. Once you have the ambient temperature, switch the vehicle to the on mode and swiftly check the HDS reading for ECT Sensor 1. The acceptable difference between the HDS reading and the ambient temperature must be less than 5.4 degrees Fahrenheit or 3 degrees Celsius for normal operation. If this difference exceeds the acceptable range, this indicates a malfunction in ECT Sensor 1, subsequently implicating it in the issues reflected by DTC P2183. Proceed with the functional inspection of ECT Sensor 2, mirroring the previous step for Sensor 1. Start the engine and let it idle for a duration of about 10 minutes. Use the Honda Diagnostic System to confirm that ECT Sensor 2's value is also above 120 degrees Fahrenheit, 49 degrees Celsius. If the reading from ECT Sensor 2 falls short of this threshold, it would signify a fault within the sensor, potentially justifying the DTC P2183. Accurate readings are critical as they directly influence the engine's performance and efficiency. The final step in the troubleshooting process requires a careful inspection of ECT Sensor 2, like Sensor 1. Allow the sensor to cool to room temperature, making a note of this value. After recording the ambient temperature, switch the vehicle to the on mode and quickly check the HDS reading for ECT Sensor 2. Again, the ideal difference between the HDS reading and ambient temperature should be less than 5.4 degrees Fahrenheit, 3 degrees Celsius. Surpassing this limit indicates that ECT Sensor 2 is likely faulty and a contributing factor to the P2183 DTC. Each inspection step is critical in identifying whether the issue lies with the sensors themselves or a connection problem. To complete the repair process for DTC P2183, it's crucial to clear the diagnostic trouble code using a compatible scanner. Following this, conduct a road test to ensure that the vehicle operates normally without generating the code again. Observe the engine's performance under varied conditions to confirm that any previous issues have been resolved. It's vital to ensure that both ECT sensors are functioning correctly and delivering accurate readings to the PCM. If the DTC reappears, further diagnostics may be necessary, indicating more complex system issues. Preventative maintenance is vital for minimizing the occurrences of DTC P2183. A key practice is to perform regular inspections of the ECT sensors. Keeping an eye on electrical connections for wear and tear can prevent future performance issues. Additionally, routinely checking the coolant levels ensures the engine can maintain optimal operating temperatures. Regular maintenance not only extends the lifespan of the sensors, but also improves overall engine performance. Staying vigilant can save drivers from costly repairs and enhance vehicle reliability. In conclusion, DTC P2183 signals a performance problem with the Engine Coolant Temperature Sensor 2 in the Honda Accord 2023 Plus. Understanding the roles of the ECT sensors and the diagnostic steps for troubleshooting is crucial for effective resolution. Following a systematic troubleshooting approach can identify whether the issue is due to faulty sensors, poor connections, or damaged wiring. Implementing regular preventative maintenance practices, including sensor inspections and coolant level checks, is essential. By recognizing symptoms early and acting promptly, drivers can avoid prolonged engine issues and ensure their vehicle runs smoothly. Please like and subscribe to the channel. See you next time.